Hey, what's up, you guys? Welcome back to my channel. Uh, I've always wanted to say that. Wow. I've never told any of you this, but I used to make YouTube videos way back in middle school. They've been scrubbed from the internet, so don't even try finding them because they were awful. But, that was every kid's dream at one point in the, late 2000s, early 2010s. So I'm just living that fantasy right now. Um, welcome to the first week of required learning. I'm just going to jump into chapter 2 from our stats book. Um, just so you all know, this is like some of the most fun I had planning because I'm not really a PowerPoint person because I like my smartboard and, writing on my PDFs like we usually do in class, but like all the cheesy ass animations I got to put into this, perfect. I had a blast. So it's going to be a great time. But today we are going to be talking about some graphs and displays, various types that are appropriate and not appropriate based on what data you've got. So I'm just going to jump right into it. Before we get into it, though, I want to review what the two types of data are first, just so we can kind of recollect what that is and get a good idea of what we're working with. So if you don't remember, first one that we've got, this is already going to be a problem. I'm like clicking and like dragging myself around, and then I have to like click on the PowerPoint again and then do my transitions. It's just, my life is so hard. You have no idea. So, first type of data we're going to work with is qualitative, and that is attributes, labels, non numerical entries, basically anything that is not a number for how you are describing some type of data. So, for example, in that episode where SpongeBob and Patrick were arguing with each other and fighting in the fry cook games, they were at the, oh God, I cannot speak. This is just like regular class. Nothing has changed. Oh my gosh. So, remember, they were yelling at each other. They were like, yellow, pink, colors. Those are qualitative data. That's a label in this case. Another one I thought of immediately was good old Perry the platypus. He's a mammal. Any type of label like that is going to be qualitative data. Amphibians, reptiles, all that. If it's not a number, it's probably qualitative data, or it just describes the quality of things. So that's the one type that we work with. The second type is quantitative data. So that's just numerical entries or counts in this case. So if it's some type of number describing something, that's quantitative data. So on this PS4 Paw Patrol game, we can see that we've got 1, 2, 3, 4, 5, 6, 7 dogs on the cover. That is quantitative data right there, just describing numbers. Or another one I thought of is the fact that David Dobrik's net worth is $7 million, which I don't think I'm Gen Z, so maybe I don't get it. It's just that's shocking right there for sure. So these are our two types that we deal with: qualitative, quantitative. Now there are tons of ways that we can display data, and that's what this is going to be all about. Even though there's lots of different ways, the type of data that you've got is going to determine how it's displayed. So whether you've got a ton of numbers or if you got a ton of labels, there's certain graphs that go with those more appropriately than others. So if you've got a bunch of quantitative data, oh man, where am I going to put this guy? We're just going to see how it works. So if you've got a bunch of numbers, there's one graph that's really good for doing those. So, excuse me. Suppose we've got prices in dollars of 30 GPS navigators down on the left right here. So I've got all my data. And so these are all various prices of GPS navigators. So one of them was $90, one of them was $130, one was $400 for some reason. Whoever bought this one really played themselves because, hello, Google Maps exists. Oh man, this is a mess. I love online teaching so much. It's a great time. So if I've got all these prices and I want to put them into some type of graph, if I want to represent it, a histogram is going to be the best way to do it down over here on the right. So why is it like that? There we go. So if you've got a ton of numbers, a histogram is a really good way of displaying it right here. It's kind of like a fancy bar graph, but for numbers. And I'm going to break that down in this next slide right here, just so we can talk about all the features of it. So got all my numbers, I got them transferred to a histogram right here. And so just going over the parts of it, these little blue bars that I've got right here are classes. So they're ranges of data values right here. So for this first bar, that's ranging from 58.5 to 114.5 and so on. They should all be an equal amount in between. So, one bar doesn't range from like 1 to 2, and the next bar ranges from like 3 to 7. They should all be the same length in this case. And these are our prices. And then the number on top of each bar is going to be frequencies. That's how many data points are in each box. So, for example, this first box I got right here, 5 of the GPS navigator prices were between $58.5 and $114.5 and so on. So I know 8 of the prices were between $114.5 and $170.5. 6 of them were between this price, 5 of them were between this price, and so on. So it's just taking all of this data right here and just kind of categorizing them. They're saying, okay, you're between these prices, you're between these prices, and we're just going to add you all up. So that's one way of doing it. And by looking at this, you can kind of tell where the regular price of them usually is. It's going to be in this, 50 to 300 range right here. Maybe you even got some that are 400 for some reason, in which case you absolutely played yourself, because Google Maps has been around for like a while. So this lesson was from our textbook, which I don't even know what year this PDF textbook is from, maybe 2007. That could explain why. Who knows? But if you've got tons of numbers, a histogram is going to be a really good representation of that. Just a fancy bar graph. So, one extra thing I wanted to talk about, I kind of felt bad that I used this same graph 3 slides in a row. It's just starting to get a little boring. So I'm just going to include some pictures of sun bears down in the corner right here, just to like zhuzh it up a little bit, just because I think they're absurd, because they've got this like little weird like sun U on their chest, and their tongues are like absurdly large, and they stand. I mean, I know a lot of bears stand, but like it's still very uncanny sometimes. And yeah, I just thought it would be really fun. They're just really absurd. I don't know why they exist, but they're great. I'm glad they do. So, one extra thing I want to talk about is relative frequency, which is the percentage of total data in each class, which is literally just calculating a percent. So, if I've got 30 total prices, which we do, 5 plus 8 plus 6 plus 5, and so on, we got 30 prices in total. If I want to find the relative frequency for this first box right here with the 5, I'm just going to take 5 divided by 30, however much divided by the total amount. You guys have been doing this your whole lives, so I know it's not a big deal. In this case, since 5 lie in that first class, I know that 16.6% of the total data is in this box right here, or the relative frequency of this class or box is at 16.6%. So if I ask you for relative frequency, I'm just telling you, hey, take that number, however much is in the box, divided by the total number of everything. That's it. You're just finding an average. It's nothing new. Sometimes they won't have the numbers on top, so you'll have to go extra galaxy brain and look at this axis on the side to try and figure it out, which you're going to be great at it. Not worried one bit. Next thing, if I am graphing qualitative data sets, so if you've got a bunch of labels in this case, this is going to be one of the better ways to do it. So suppose I've got data of earned degrees in thousands from 2007. Since the classes are qualitative, one method of displaying it is going to be with a pie chart. So first off, here's my data. I know what you're going to be thinking, Mr. Cecil, these are clearly numbers. Is that not quantitative data? Not in this case, because as we can see, these numbers represent a type of a degree, a label in this case. So, when these people were, I don't know, filling out the survey or whatever, all the results were a label. So it was associate, master, bachelor, and so on. They just added up the total number in this case. So I've got a bunch of labels, as my data. So a good way to represent it is a pie chart. Classic, elegant, sometimes. Sometimes they can be ugly. We've looked at some ugly pie charts before. But this one works out really well. So in this case, they're just taking the total number of degrees and just find the percentage of them, which you're all wonderful at. I know you're not going to struggle with it at all. And they just made it into an elegant pie chart as such. So we got our bachelor's, associates, masters, that kind of thing. So if you've got qualitative data, pie chart, classic, works very well. One other thing I'm going to ask of you is what could be some conclusions you can make about each type of graph? So what statement could be made? What could you assume about it? So obviously, big one that I would think of is that bachelor's degrees make up a little more than half of the conferred degrees, or the majority of the conferred degrees. That could be one thing that you could say about it. It's always going to work out. If you're trying to make some type of a conclusion about something, looking at whatever has the biggest chunk of the pie chart is always going to be a good conclusion to make. I would also look at maybe what has the least amount. So another conclusion you could make is the doctoral and professional degrees make up a very small fraction of the conferred degrees, or they make up the least amount or the least likely to be given out. Those are all things you could say about this in this case. So whenever I'm asking you to make a conclusion about something, usually looking at whatever's got the biggest chunk and whatever's got the smallest chunk, those can be good conclusions you can make. And of course, I had to include a picture of The Bachelor and McDreamy because a bachelor and a doctor. My mind, I know. One extra thing is that, of course, if you've got a bunch of labels, qualitative data, another way you could represent it is with a classic bar graph. It's just like the histogram that we looked at before, only in this case, our boxes or our classes, instead of having a range of values on the bottom, it's just going to be a label instead. And they're not going to be connected in like a big kind of like hill. In this case, they're all going to be separate because, one label doesn't really go with another one. So this one is looking at main causes of inventory shrinkage in the billions of dollars. So for all my people who have worked retail jobs, if something goes missing or is lost, that's accounted for. I worked at Lowe's in Coralville, and the loss prevention person who was in charge of that was literally the most terrifying person I've ever met. He was super serious about stuff getting lost. He got fired. I don't know why. Uh, I just came back one summer and he was gone. No one really talked about it. It was a weird place. But the people in charge of that, and they're always keeping track of reasons things go lost. So we've got employee theft, shoplifting, admin error, vendor fraud, all the different ways things can go missing or your inventory can shrink. So if I asked you to make two conclusions about this, again, one of the best things to do is look at what's got the most amount. So you could say employee theft makes up the majority of inventory shrinkage because it's the biggest bar. It's $16 billion, which, maybe those employees just really wanted that Snickers bar over lunch and just little. I'm not condoning it. I'm not endorsing it at all. I'm just saying, it's there. You're working. It could happen. Never done it myself, but I understand. Second thing I thought of is that if you wanted to make one conclusion, you could maybe combine things that are a little smaller. So you could say that shoplifting makes up for more than double the inventory shrinkage of admin and vendor fraud combined. Because in this case, it looks like shoplifting is about 13, whereas admin error is about 5, vendor is 1. So even if you added those two up, they still wouldn't even make double of what shoplifting is in this case. That's another conclusion you could make. There's tons of others you could say as well. You could say vendor fraud is the smallest majority, it's the least likely to happen. Tons of things you could say. But usually focus on the biggest chunk and the smallest chunk if you're trying to make some type of conclusion. I need to get a drink of water. How's everyone doing, by the way? I just want to say I miss all of you. And I wish I could be in school again. But at the same time, I love sleeping in. But that doesn't change the fact that I miss all of you and would like to see you. Anyways, last little thing I want to talk about is if you've got paired data. And I've never really talked about that before. So if you've got two different data sets and you can correspond them in some way, that creates paired data if you're trying to relate them in some way. And this only applies to quantitative data. So if you've got one list of numbers and another list of numbers and you want to see maybe how they relate, this is what you got to do. So one thing I want to look at, another situation is, suppose we want to see how two different data sets from 12 factory workers are related. We want to compare their weekly hours and their wages. So here's our data first. So this is what your data is usually going to look like. It's going to be one column in numbers and another column in numbers. If you see something like this, best possible way that you want to graph it, if they're both quantitative like this, is going to be with a scatter plot like this. So it's just a little graph with just a smattering of dots everywhere. So every little row on this table represents one of our workers. So one person filled out this survey, they work 33 hours and they make 1216. Another person said, I work 37 hours and I make 998. And they graphed all of those little pairs on there. Purpose of a scatter plot is to look for some type of trend, like, okay, does your number of hours affect the hourly wage? If you work more or less of something, does that affect the other one? And in this case, I'm looking at this scatter plot. It's kind of garbage. There's not really a trend I can see. Because if we look down here at this bottom row right here, it looks like, okay, all three of these people make kind of the same amount, but they work way different hours, right? One's working about maybe 27, the other one's working 45, and they make the same amount. Also, if I'm looking at maybe this column right here, I see these two people work 40 hours, but this person makes a little less than this person up here. So looking at this, if I asked you what trend do you see as one thing goes up, does the other go up, and vice versa? There's not really a trend in this one. It looks like number of hours worked does not affect your hourly wage. So I didn't want to stop at this example. I wanted to show you what other possible paired data sets could look like as well. So other various scatter plots to look out for. If I was asking for a positive trend, it might look something like this. So this one's comparing quiz scores versus exam scores, which makes sense, right? It's showing that as people do a little better on their quiz score, they're also doing a lot better on their exam score as well. So if you see some type of sloping upward line like this, that's usually going to indicate a positive trend. It's looking like as one goes up, the other one goes up. Second one to look out for, a negative trend, which is just the opposite. So this one's comparing number of missed classes and exam score, which is something that some of you could probably relate to every now and then. So it's showing that as you miss more classes, it looks like your exam score is going down a little bit. There are some maybe interesting cases that don't fall in line with this. Like these dudes right here, looks like they missed 20 classes, but still managed to scrape by with like a middle C or something like that. But the general trend that we can see is that less class you miss, higher score you get, more class you miss, lower score you get. That's just how it goes. And the last one in this case could be a neutral trend, or what I refer to as a garbage trend, because it's just a big smattering of dots. There's nothing to work with at all. This one is showing shoe size versus IQ, which, even thinking about that, it's like, duh, those are not related at all. We can see on this, where'd my mouse go? We can see on this bottom trend right here, I got a bunch of dots where they scored super low, but they've all got the same shoe size. Or like right here around the 20 shoe size, we got a bunch of them in this range, but they all scored different IQ scores. So if it's a weird smattering of dots like this where you can't really see something like going up or going down or vice versa, that's going to be a neutral trend or just nothing. They're not related at all. So that is all I wanted to do for today. Yeah, I've never really done one of these before. I thought about starting the video off with "What's up, Ace Family" or something like that. I don't know. We'll see later. But this is so weird. It's like I'm talking to all of you, but you're not really there. So I don't know what else to say really. Reese, I know you probably love watching whatever the new Trolls movie is right now. Make sure you're paying attention to me. And yeah, so Have a good one, everyone.